Hello, the purpose of this video is to go through advanced stoichiometry homework. I believe this was homework 8, if I'm not mistaken. Question number 4, the titration. All right, so first of all, what is a titration? They said to go see challenge from homework 2. And if you go look that up, you'll see that a titration basically involves a burette that has a solution of known concentration. You add that into an Erlenmeyer flask where you have a known volume of a solution with an unknown concentration. So you have some solution down in the Erlenmeyer flask where we do not know the concentration. You add the known solution dropwise. That just means drop by drop. So if I have my solution in here, I'm adding it drop by drop into the other solution. They're going to react, and you stop adding the solution when both reagents have reacted completely. So meaning neither one is in excess, neither one is limiting, and both have just reacted exactly, completely. And you can usually tell that this has happened because of a color change. You use some kind of indicator that will change color when the solution is complete. All right, if you're not feeling confident on that explanation, go back and watch that part of the video again until this setup makes sense to you. All right, so now let's take a look at the problem. So ethane dioic acid is a diprotic acid. That means it can lose 2 protons or 2 H plus ions. A student determined the value of X in the formula of hydrated ethane dioic acid. So we have the ethane dioic acid with some amount of water. By titrating a known mass of the acid with 0.1 moles per decimeter cubed NaOH. So I'm just going to draw this setup here and fill in all of the information that they've given me. So this is HOOC, COOH, X, H2O, and this one is 0.100 mole per decimeter cubed NaOH aqueous. And of course we add the NaOH aqueous into the ethane dioic hydrated acid there. All right, in order to make this sample here, how is this sample made? Well, this sample comes from a larger sample of ethane dioic acid, 0.795 grams of hydrated ethane dioic acid in 250 cubic centimeters. And then we took out just 25 cubic centimeters to do the titration. So it's pretty common to make up a big sample and then in order to get multiple trials, just titrate a part of it, take out something like 25 cubic centimeters. All right, so let's go ahead and take a look at the actual problem. Okay, so let's go ahead and get into the math. Section A, calculate the average volume of NaOH added in centimeters cubed, and then find the moles for titration 2 and 3. All right, so these are pretty common readings or recordings from a burette. A burette, it's kind of an interesting glassware instrument. 0 is down here, and then whatever the max is up here. And so you record between where the volume is. So maybe you start the solution up here at 50, you release some to do your titration. All right, and so then maybe the volume moves down. Whoops, moves down a little bit to down here. Well, then you would record this difference to get the volume of NaOH added. All right, so I'm just going to subtract to find these two volumes. 25.7 minus 13 is 12.7. And 20, whoops, that's a 30. 38.2 minus 25.7 is 12.5. So 12.7 centimeters cubed plus 12.5 centimeters cubed over 2. To find the average is 12.6 centimeters cubed. And then I just need to find the moles. Centimeters cubed. I have the concentration. So I'm going to get this into centimeters cubed, 1 decimeter cubed. This is, of course, NaOH aqueous times 1 decimeter cubed, 0.1 mole NaOH. All right. 12.6 times 1 divided by 1,000 times 0.1. It's really, you should be able to do in your head, but we're on paper 2, so I just plugged it into the calculator. All right. B. And B, they give us a reaction. Great. It is very common that whatever answer you just got in A, you're probably going to need to use in B. So now I have moles of NaOH, and B is asking for moles of ethane dioic acid. All right. So 0.00126 moles of NaOH, starting with that amount I just found. How do moles of NaOH relate to moles of ethane dioic acid? I can do that with coefficients. So 2 moles NaOH, 1 mole ethane dioic acid. All right. And I'm finding the amount in moles, so I can just stop there. So this is 6 times 3 times 10 to the negative 4 moles of ethane dioic acid. And as a reminder, that was in my Erlenmeyer here. So in 25 cubic centimeters of ethane dioic acid. Remember, we just titrated 25 cubic centimeters. So then in C, I need to find the amount in all 250 cubic centimeters. So I'm just going to take that amount in 25 cubic centimeters, and multiply by 10 to get the amount in 250 cubic centimeters, because to go from 25 to 250, I multiply by 10. So 0.0063, and you can report in scientific notation or not. Either is okay. HOOC, COOH. Great. Now D, well, D, I need to find the molar mass, which is grams per mole in terms of units. The grams of ethane dioic acid that I have is 795 grams. And the moles, 0.0063 moles. 0.795 divided by 126.19 grams per mole. And remember, we were dealing with the hydrated ethane dioic acid. So this is the molar mass for HOOCCOOH with the water ligands with some amount of water associated with each molecule. All right, E I consider the only one to be a little bit challenging, but they really prompt us with how we can approach it. In D, they had us find the mass of the hydrated molecule, the molar mass. So let's go ahead and find the molar mass of the anhydrous without water, ethane dioic acid. So I have carbon, 2 carbons, 1.01 times 2, 2 hydrogens. Oxygen is 16 times 4, 24.02 plus 2.02 plus, all right, 90.04 grams per mole. The difference in these molar masses comes from water. All right, so the difference in the molar masses comes from water, 126.19 grams per mole minus 90.04 grams per mole equals 26.19, 36.15 grams per mole. So how many moles of water is that? Well, 36.15 grams times 18.02 grams. That's the molar mass of water. 1 mole of H2O. 18.02 equals 2. So that means X is equal to 2. The hydrated molecule is HOOC, COOH times 2 H2O, meaning there's 2 water molecules associated with every one hydrated ethane dioic acid when it is hydrated. All right, hope that helped.